topic that I want to hit is one last family of trig identities. These trig identities are identities which translate between products of trig functions and sums of trig functions. And their use is fairly niche, which is why it's put off to the last thing in the semester, but they're still worth hitting. There are lots of times when it's more convenient to think about products as opposed to sums, or sums as opposed to products. I guess one example would be if you want to think about logs. Right? It's nice to have a product inside of a log. It's unpleasant to see a sum inside of a log. You can't do anything with this sum. So let's just try to get that formula. And the argument for why such a formula should exist is reasonably straightforward. Oh, cool. I left all my pens behind. We have a thing that computes sums of a trig function of a sum. Let's use it for a formula like this. So if you see cosine of a minus b plus the cosine of a plus b, does that look like something we could use angle addition to compute? How many people have the angle addition formulas just in their brain? Cool, that's right. I'll write them down up here because they're worth having down. So if you want to add up two angles inside of a trig function, the way you do that is you multiply the cosine of the individual angles. And then you subtract the same thing but with sine. I know one had it like right at the tip of their brain, but now that it's written down, it looks familiar, I hope. Cool. And if that's what you do for plus, what do you think you do for minus? Yeah. So I think that's all we need to do this next line. So let's try to compute cosine of a minus b plus the cosine of a plus b and see what we get. And this will seem like an arbitrary exercise to do, but let's do it. Something interesting will happen. So, cosine of a minus b. Let's see, according to that formula, that is cosine of a, cosine b, plus sine a, sine b. There's the first step written out. Now let's add the other one. Plus cosine of a, cosine of b, minus sine of a, sine of b. Well, I put those parentheses just to help me remember which b's corresponded to which ingredient in the previous line. Do those parentheses actually matter? No. It's all addition, so there's no like distribute the minus sign to do, so we're good there. If you look at that, do you see anything that cancels in that formula that might help us simplify? Yeah, what cancels? Yeah, the piece with the signs. And then the other two are just like the same thing added to itself. So it looks like what I see here is just 2 times the product of cosines. And what we did there was kind of arbitrary and random feeling. But let's take a look at this table of formulas. So if you wanted to know cosine of a times cosine of b, does that formula basically just like tell you what cosine of a times cosine of b is? Yeah, what would you do to get cosine A and cosine b on its own? Yeah, divide by 2, right? Nothing fancy here. So let's divide both sides of that by 2. That'll go in this box. So apparently cosine A times cosine of b is exactly the same thing as 1/2 multiplied by cosine of a minus b plus the cosine of a plus b. Cool. So one interpretation of this is if you ever see a product of 2 cosines multiplied by each other, and you would rather see a sum, Maybe you're doing some operation which is complicated under multiplication, but easy under addition. Then here's a thing you can do. You can always replace a product of cosines with that sum of cosines. Nice. Do you think we could do something similar to get formulas for the other things? Nice. So, here's what I'm going to in fact have you do. Do you think the walk to figure out that formula is going to be like the exact same? Do you think it'll be any more complicated to get that formula? Except I guess we need to have the angle addition formula for sines. So I'll put that on the board. And maybe you'll even remind me what it is. What's the sign of a plus b? Sine a cosine b.
Plus cosine a.
Cool. And how does it change if there's a minus sign there? Cool. So, now that we have the angle addition formula for sine, do you think both of the next two things are easy to walk out? Nice. Cosine a minus b, cosine a plus b. Sine a minus b, sine a plus b. As soon as you just have a thing that goes in either of these two boxes, and you're confident, go ahead and let me know something that goes in one of those two boxes.
Does the middle one just cancel?
I don't think it all cancels. Let's write it out and see what happens. I think that there's an issue in distributing a minus. So let's talk through item 2. Presumably it can't all cancel to 0 because cosine of a plus b isn't always the same as cosine of a minus b. So let's go ahead and see. And maybe before I even do, anyone get something for this item that is not exactly 0? What'd you get?
When I simplified everything, I got 2 sine a sine b.
All right, so let's see if we can get that. So, I guess first things first. What's the cosine of a minus b?
Cosine a
Cosine a
cosine b.
cosine b plus sine a sine b, and I'll put parentheses for emphasis. Then I need to subtract cosine a plus b, which is the same thing again, but with an extra minus sign. Cosine a cosine b minus sine A sine B. People feel good? All right, and now the parentheses do actually matter. Like a negative sign outside of a parentheses needs to be distributed. So let's distribute it through and see what happens. Should I do it in a new step or distribute all in the same step? New step? Same step. Cool. So I guess that'll be a plus. That'll distribute there to be a minus, and this will become plus. Now that we've done that, what cancels? The cosines and the sines stack now? Cool. So apparently cosine A minus B cosine A plus minus cosine A plus B is 2 sine A sine B. So which row in that table does that let us fill in? The middle one, I guess, by dividing by 2. So apparently sine A sine B is the same thing as 1/2 cosine A minus B minus cosine A plus B. And it all needs to be divided by 2, so again, parentheses matter. So the folks who did the thought item, is it clear what should go in that bottom box now? What did you get? Down here. Or possibly what did you get this to simplify down to?
I got 2 sine A cosine B, and then keep the box and have the answer for that, but I don't know if it's right.
Cool. Well, happily, I have a pencil which can be erased, so let's hear it.
1/2 sine A minus B plus cosine A plus B.
Interesting. How did you get that?
Sorry.
Oh, okay, sorry. Okay, yeah, then I'm happy.
I misspoke. Yeah.
Okay, then, yeah, the interesting goes away. Yeah, that's right. Cool, you just took this equality and divided by 2. Cool. Does anyone want to see that thought bullet point expanded on any more detail, or are people feeling pretty good? Cool. It's the same work again, right? Use angle addition, and then there's not even the issue with distributing the minus sign. You just see what cancels. Cool. So now that we have these formulas, let's use them to do something. Again, their use case is a little bit niche, but whenever you see a product of trig functions and you'd rather see a sum, you can use them. So let's use it, for example, to rewrite this product as a sum. So on the one hand, we do theoretically know what the cosine of 5 pi over 12 and the cosine of pi over 12 are. In fact, how many people just remember what they are already? Yeah, okay, cool. Yeah, right, you would get them by like the half angle formula or angle addition depending on what suits your fancy. But let's see it in terms of not that. So I see a cosine times a cosine. I should use this formula. This is the exact same thing as 1/2, big parentheses, cosine of the difference, 5 pi over 12 minus pi over 12, plus cosine 5 pi over 12 plus pi over 12. Let's try to compute that. So the 1/2 stays put. What's 5 pi over 12 minus pi over 12? 4 pi over 12. And same thing as pi over 3. So right off to the side, 5 pi over 12 minus pi over 12 is 4 pi over 12 is pi over 3. Nice. Is pi over 3 an angle that we know the cosine of? That's nice. All right, same thing, but 5 pi over 12 plus pi over 12. I go pi over 2?
No, 6 pi over 12.
6 pi over 12, which is the same as pi over 2. Plus cosine pi over 2. All right, and those are either things that you just know, or you know how to read off of the unit circle. What's the cosine of pi over 3? A half. So this is 1/2 times 1/2. What's the cosine of pi over 2? 0, right? Pi over 2 should be a right angle. The x-coordinate at a right angle is 0. Is a quarter. Neato. How do people feel about that? Do you think it's worth spending time doing 2 more similar computations? Is there interest in doing that on your own now and then coming together? Cool. So I guess same breakup. So I guess maybe I'll switch things. So like who's doing the sine and who's doing the sine cosine switches. So sine 5 pi over 12 times the sine of pi over 12. Sine 5 pi over 12 times cosine pi over 12. And as soon as you have an answer that you feel happy with, that maybe you've even checked against some people around you, again, I guess the folks on the right-hand side of the room, if you want to rearrange yourself so you have people to talk to, I think that's okay at this point in the semester. All right, what are we getting on this side? I think I've seen a few people who look happy. What'd you get? Also a 4? Feel good? Cool. That was this one. Cosine 5 pi over 12 times the sine of 5 pi over 12. What'd you get? You have 2 plus root 3 over 4. Folks agree? People want to see a walk through, or are people happy? Nice. All right. So, there's the product to sum formula. Whenever you see a product of trig functions, you can get a sum. If you go from products to sums, one assumes you can go from sums to products. In fact, here, let's go from sums to products. And let's do so by using the product to sum formulas, which unfortunately are on the other side of the page. So maybe I should start by putting them at the top of this page. Cosine cosine is 1/2 difference plus sum. And I'm going to use different variable name now. Cosine x cosine y is 1/2 cosine of difference plus cosine of sum. X minus y plus cosine x plus y. Cool. So let's use that formula, which hopefully I've copied down correctly, after changing a and b into x and y. Let's use it to accomplish something. Let's use it to compute 2 times the cosine of a plus b over 2 times the cosine of a minus b over 2. And again, that seems like a really random thing to want to compute. But we'll see why that's a useful thing as soon as we've done it. So let's do that. So this 2 I'll just carry along as a 2. This 2 is the same as that 2. Times, oh neat, oh that's nice. You'd think that by a whole semester of doing this I'd have gotten used to the fact that I had to press AFL at the start of class. I mean, no one stopped me yet, so it couldn't have been that bad. I see a product of cosines. I have a formula for the product of cosines. Let's use that. So this will be 1/2 the cosine of the difference between these two things. Cosine of a plus b over 2 minus a minus b over 2 plus the cosine of a plus b over 2 plus a minus b over 2. Let's see, that's enough parentheses? No, it's not. That 1/2 needs to be multiplied by everything as well. Now it's enough parentheses. Neato. So in looking at this, we want to presumably simplify this as much as possible. What simplification do you see? What's 2 times 1/2? 1. So like the first 2 things you see cancel each other. And let's look at this piece and that piece individually. Maybe that one's the easier one to start with. So maybe I'll even try to do this without writing anything. Between those 2 fractions, these 2 fractions, is there a common denominator? Nice. So those fractions are easy to add. And let's try to do the adding and everything. So everything will be divided by 2. And what will the numerator be? I guess it'll be a plus b plus a minus b, which is the same as just a at the end, so just 2a in top because I already have the 2 down there. But yeah, we'll simplify down to a. Neat. That feel pretty good? Anyone want that seen in any more detail than the none that I provided? Cool. Same thing with this. What does that piece simplify down to? To be over 2, I hear? People buy that? Right, distribute the minus sign through. Oh, cool. So that is exactly cosine of b plus cosine of a. Oh, hey, have we just found a formula for what the cosine of a plus the cosine of b is? Yeah, nice. It's right there. Cosine a plus b is 2 times cosine of the average. Yeah. Times the cosine of the difference over 2. Bangarang. People feeling pretty good? All right, so let's try to figure out what goes in the second column by even just doing the same computation again for the sine and a sine multiplied together. Do we have an angle addition formula? Do we have a formula that goes from a product of sines to a sum of trig functions? Yeah. And maybe I won't write it at the top of the page, because it'll be pretty similar to what's already at the top of the page, and you can't see the top of the page now anyway. It'll have something to do with this, so sine times sine is 1/2 cosine of the difference minus the cosine of the sum. So let's use that. So this will be, this 2 will come along for the right, times 1/2 cosine of difference minus cosine of sum. A plus b over 2 minus a minus b over 2 minus cosine of the sum. A plus b over 2 plus a plus b over 2. Okay, does that look like pretty similar to what we just did? I think it does. So by following like the same steps as up there, let's see what that simplifies to. What is the thing in this parentheses really equal to? I think it's B. Is it B? Cool. Let's put a B there. What's in the other parentheses? A. In fact, by the exact same walk as above. In fact, you didn't even have to do the walk again. You could say, oh, I did it like literally in the previous line. I don't need to do it again. Cool, so cosine of B minus cosine of A. Cosine of B minus cosine of A is the same as 2 times the sine of the sum times the sine of the difference. Cosine B minus cosine of A. Nice. So I'm running pretty close to when I want to hand out the things. So I think I'm going to wind up making it through this page. Maybe as a pro tip, the topic of this particular lecture will not appear on the coming midterm. So I feel okay putting off some of the stuff on this page until, I guess, after the review for the midterm and then after the midterm itself. So that'll just be the last page. We'll hit that on Wednesday. But let's finish this page. So, same thing again. Sine of A plus B times the cosine of A minus B with some divide by 2's in there. Let's write out what that is. So possibly by flipping to the previous page, that's the same thing as 2 times, let's see, it's a product of a sine and a cosine. So a product of sine times cosine becomes what sort of thing? Sine plus cosine, cosine plus sine, what sort of thing are we looking for? Sine minus sine? Sorry, not quite. Sine plus sine. I was legitimately asking. These are sufficiently niche formulas.
And they're 1/2.
Yes, which is going to screw everything up. I need space for the 1/2 and the parentheses. And inside of the parentheses, is it a sum then a difference, or a difference then a sum, or what? Difference and then a sum. Oh, neat. So have we already walked over the difference between the two things in those parentheses there? What's the difference between the two things in those parentheses? I hear a B. What's the sum of the two things in those parentheses? A? Oh, the 2 and the 1/2, what happens to those? Have we just figured out what goes in the next line? Cool. Whenever you see the sine of A plus the sine of B, you can replace it with 2 times the sine of the average times the sine of the difference over 2.
What does it say in the second box on the left?
This one?
Yeah, what does that say?
Yeah, let me write it big O. So I guess it's that, right? Because that's the thing we got to be the thing that is that. So cosine of B minus cosine of A is equal to that thing. Yeah.
The box should be cosine.
Oh, yeah. Nice. Now we happy? Perfect. Yeah.
So in the second one we did, with the sine and sine,
Mhm.
the second part, are there supposed to be 3 pluses there? Or is one of those supposed to be
Well, there's supposed to be 3 pluses.
like this part? Oh, the second part. It's kind of like,
Oh, yeah, I was sloppy, wasn't I? You're objecting to this minus sign, right?
yeah, I was just.
Yeah, yeah.
Thank you.
'Cause that should have been the
I got
same.
confused.
No. You were right. I was confused. Cool. So now that we have those 3 formulas, there's a fourth one in the line, and you'll notice there's not a space to walk it out. But, well, wait. Tell me about sine. Is it even or odd? Odd. So that minus sign, where could I put it? I could put it inside the parentheses. So this is the same thing as the sine of A plus the sine of minus B. Oh, neat. Do I have a formula that says what the sum of 2 sines is? Yeah. So let's use that formula and just replace B with negative B. That seem like a plan? Cool. So apparently that is the same thing as 2 times, well, let's just think what would happen. So that B will become a minus B, so that'll be an A minus B over 2. This will become an A plus B over 2. And I guess maybe if I want to keep the A plus B and the A minus B in the same spot in the column, I guess I would just switch the sign and the cosine. People feel pretty good? Yeah, there's the next line. Cosine of A plus B over 2 times sine A minus B over 2. So the game is, now, whenever you see a sum of trig functions that you would rather see as a product, you can realize that by just using these formulas. And I think with there, I'll stop for today. I will get these out. Don't circulate any information on this regarding your views on the class yet. I cannot be sure what that happens. No, let me smoke it all. And I will read one bit of instruction. I'll put this here, and we've got to put your up scan in the portal, and you have yours filled out. It's been a semester. All right, put your instructor's name, Christopher Davis, or just Davis is good enough. Course number, Math 112. Section number 003, and date May 5, I think, at the top of the outscan sheet. Do not fill in the ID number section. Use a number 2 pencil to mark the outscan form. Does anyone not have a pencil? You want a mechanical one or a normal one?
I'll just get the one.
Okay. If anyone else needs a pencil, they are there. If a particular item does not apply to this instructor/course, or if you have had no opportunity to make a judgment about this item, then use E, no opinion, as your response. This is to be completed anonymously, black and circle on the off-scan sheet, which corresponds to your reaction for each statement using the appropriate categories. Okay, bye. I have an office hour at 3 if anyone wants to talk to me later.
He's walking in the hallway with no shoes on. It's my voice now.
Way too long to realize how to fill the bubbles.
Oh.
It's so confusing to me.
Well, it's like, 'cause it's not like even with the questions.
No, I didn't even realize that they had like the numbers next to the
Oh.
questions, so I was so confused. I was like, how the hell am I supposed to go back?